Hello everyone and welcome to another video. Okay, so in this video we'll be talking about cross product of vectors. Okay, so we'll be talking about cross product and then dive right into triple product. Okay, so let's get right into this video. In case you are new here, kindly subscribe. Okay, subscribe and hit on the bell icon so that you don't miss out on any uploaded video. Okay, without further matter ado, let's dive right into this video. Okay, so when we talk about cross product, okay, cross product of vectors, it's what we are trying to multiply two vectors but using the cross product rule. Okay, we are trying to multiply two vectors using the cross product rule. Okay, so it's like finding the determinant of two vectors. Okay, so let's say you have vector A. Okay, let's say you have vector A with A1, okay, and A2, okay, and then you have what, vector B, okay, with what, B1 and what, B2, okay, and you are told to find what, the cross product. So the cross product will be this. Okay, so cross product of the two vectors, what, A is A1, A2, okay, and then what, B1 and what, B2, okay. So unlike the dot product, for the dot product you have to just multiply the corresponding variables and then what you add. Okay, but for the cross product, this is how we solve it. You use the determinant. Okay, so you have what, A1, A2, and then we have what, B1, B2. Okay, try to understand the determinant because you'll be using it throughout your matrices algebra. Okay, so it's like cross multiplication. So you multiply A1 by B1, okay, multiply this by that, and then you multiply this by that. Okay, so multiply A1 by B1, A1 by B2, okay, and then you subtract that from what, A2, and then what, B1, okay. So that will be your final answer. Okay, right, let's take a simple example. Okay, right, so let's say we have a certain vector A to be what, 2, 1, okay, and then you have another vector B to be -6, 4, okay. So let's try find what, the cross product of AB. Okay, so cross product of AB will be equal to what, let's put it in this form. Okay, the determinant form. So you have what, 2, 1, and then what, -6, 4. Okay, so when you do your simple calculation, okay, you have 2 by 4, okay, so 2 times 4, okay, -1 by what, -6, 1 times -6, okay. When you simplify this further, you end up with what, 8 minus what, -6, okay, right, and then you end up with your final answer to what, 14, okay. This is what, a 2 by 2 determinant, okay, a 2 by 2 determinants. Now let's move on to what, in case you are given what, 3 by 3 determinant, okay, or 3 by 3 vectors, okay. So this is how it will look like. Okay, it's the same principle. So you have what, a certain vector A, B, and what, C. Okay, so finding what the determinant will be A1, A2, A3, okay, and then we have B1, B2, B3, and then we have what, C1, C2, C3, okay. Yes, so that's what the principle. Okay, so when finding the determinants, this is how it works. Let me use colors. Okay, so let's say you are finding the determinant for, sorry, let me clean this one up. Let's say you are finding the determinant for what, A1, okay? We are concentrating on A1, okay? This is how it works. Listen attentively so that you don't miss out on anything, okay? Now, when you are using A1 as the reference point, okay, this is how it works. You concentrate on these, okay? Okay, we concentrate on B2, B3, C2, C3, okay? So it means that once working on what? A1, anything behind and below A1 are omitted, okay? Anything, any value, okay, or any vectors, being it on the right side or left hand side of what? The specific vector in reference, okay? And then anything below or above it is what? Omitted, okay? So from A1 we could see that the vectors A2 and A3 are what? Beside A1, and for B1 and again B1 and then C1 are what? Beneath A1, okay? So any vectors beside or above or below the vector in reference, do not, we omit them, okay? We do not add them in the calculation. So we have what? We have what? A1, open bracket, what? B2, B2, B3, okay? C2, C3, okay? Minus, okay? And let's move on to what? A2, okay? So for A2, let's use our reference point to be what? A2. Now, when using A2 as reference point, as we stated earlier, anything below or above or beside A2, that's the reference point, is omitted, okay? So you could notice that A1 and A3 are what? Beside A2, so they are omitted, okay? And then we have what? B2 and what? C2 are also beneath what? A2, so they are also omitted. So leaving what? B1, C1, B3, C3, okay? So that's it. So we have A2, we have what? B1, B3, okay? And then we have what? C1, C3, okay? Plus, okay? So let's move on to what? A3, okay? So for A3, as stated earlier, anything beside the vector in reference, and then anything below the vector in reference or above the vector in reference, okay, is omitted, okay? So from here you know that A1 and A2 are beside what? A3, so they are omitted, okay? And then what? B3, C3 are what? Below A3, so they are also what? Omitted, okay? So leaving what? B1, B2, C1, C2, okay? Yes, so we have what? A3 giving us what? B1, B3, and we have C1, okay? Sorry, this is B2, this is B2, and then we have what? C2, okay? Now, hope you understood this portion, okay? Anything behind and what? Below, okay? So we use the mnemonic BB, okay? We use BB as your shortcut trick, okay? So we use BB. Anything behind and what? Below. So anything behind and then anything what? Below your reference what? Vector, okay? Anything behind, anything below your reference vector. So from here you can notice that we have what? A simple determinant again, okay? Just like the 2 by 2 make calculation, okay? So you just multiply across. So we have what? B2C3, okay? B2C3 minus what? B3C2, okay? And then we have minus A2 with what? B1C3, B1C3, and then what? B2 what? C1, okay? And then you move on to what? A3, we have what? B1, C2, okay, minus what? B2, C1, okay? Now, let's proceed, okay? So now, there's one thing you need to know, okay? There's one simple thing you need to know. Okay, so let's say you have a vector, okay? And then it's being represented in what? I, J, K, okay? The vector is being represented in what? I, J, K. And then you are to define what? The cross product, okay? This is how you solve it, okay? So now, let's say you have vector A, vector B in what? I, J, K, okay? This is how you go by the calculation, okay? So, you apply the same principle, but you introduce what? I, J, K, okay? So now, let's say vector A has three values, A1, A2, and what? A3, okay? And then let's say vector B also has three values, B2, and what? B3. So use the same principle over here, okay? But instead of what? A1, A2, A3, they tend to change as they tend to change, and then they are being replaced with what? IJK, okay? So we employ the same principle. Now, there's one secret you need to know, okay? There's one secret you need to know that deals with what? The signs, okay? Whether it has to be positive, negative, or whatever, okay? But we normally employ what? Positive and negatives, okay? So now, for the first row, okay, we employ what? Positive, okay? For the second one, we have what? Negative, and then for the K side, we have what? Positive, okay? So this is how the operation signs work, okay? So when you are taking I as a reference, this thing has to be, your operation sign has to be what? Positive. When you are taking J as a reference, your operation sign has to be what? Negative. And then when you are taking K as a reference, your operation sign has to be what? Positive. So let's employ the same principle over here, okay? So you have what? This has to be positive, okay? So you have positive what? I, okay? With our what? Determinants, okay? So from here, the same principle applies here. We are using I, so anything below and then behind, anything below and beside I are being omitted. So we are being left with what? A2, A3, B2, B3, okay? So we have what? A2, okay? A3, and then we have what? B2, what? B3, okay? So now we move on to what? J, okay? So J is what? Negative, okay? So we have negative J, okay? With our variables, anything beside and below J, okay? So you have I, K being beside, and then A2, B2 being beside, okay? So they are being what? Omitted, okay? So you have what? A1, you are being left with A1, A3, and then you have B1, B3, okay? And then let's move on to what? K, okay? So for K, we have what? Positive K, okay? So for K, we have positive K, and then we have what? Anything beside K is being omitted, and anything below K is being omitted. So we are using what? So we are using what? The B is to B principle. Anything beside the reference point and anything below the reference point, okay? So we have what? Anything beside this thing, the K is being omitted, okay? And then anything below the K is being omitted. So A3, B3 are being omitted, I and J are being omitted, leaving us with what? A1, A2, B1, B2. So we have what? A1, A2, and then we have what? B1, B2, okay? Now, so let's further simplify this, okay? So we have what? We have I, okay? And then multiplying across, just like here, okay? Just like initial example. So we have what? A2, B3 minus what? A3, B2, okay, minus J, which is A1, B3 minus what? A3, B1, okay, plus our K value, okay, which is A1, B2 minus what? A3, let's say, okay, as A2 over here. So we have what? A2 and then what? B1, just like here, okay. Now, let's take what? An example so that you get to appreciate the entire principle, okay. So now, let's say we have what? Vector A to what? I plus 3j, okay, and then what? Plus 4k, and then we have another vector B to what? 2i minus 7j minus 5k, okay. So to find what? The cross product, okay. So you have A by what? B, okay. So that will give us what? I, J, and what? JK, and then we represent our what? A and B's, okay. Vector A and B, so you have what? This coefficient of I is 1, and you have what? 3, and then what? 4, and then for B we have what? 2 minus 7, and then what? Minus 5, okay. Now let's proceed with this expansion, okay. So we have what? Just like you stated earlier, anything below and what? Beside, okay. Below and beside, okay. So yeah, for I we have what? 3, 4, 7, and what? Minus 5, okay. So let's check again this, okay. So we have what? And then we have what? Minus j, okay, going into 1, 4, 2, and what? Minus 5, okay. That's for j, and then we move on to what? K. For k we have what? 1, 3, 2, 7, okay. That's negative 7, okay. Now let's move on. So we have what? I. So we have what? 3 on what? 15. So we have 3 times 15, that's what? Minus 15, okay. And then minus what? Minus 7 and 4 will give us what? Minus 28, okay. Close that, and then minus j we have 1 by 5 will give us what? 1 by minus 5 will give us minus 5, minus 2 by 8 will give us our k, okay. 1 by minus 7 is what? Minus 7 minus what? 2 by 3 is what? 6, okay. So this simplifies further. This will give us 13i, okay, minus what? This portion, minus this, minus 5 minus 8, that's what? Minus 13 plus ij, okay. So we have positive 13j, okay, and then this will give us minus what? 13, okay. So minus 13k, okay. So this is our final answer for this example, okay. So you can try other examples, okay. So let's move on to what? Triple products, okay. Let's move on to triple product. Triple products. Triple product is all about implementing our what? Dot product and what? Cross product, okay. So triple product is we try to merge the dot product and what? The cross product, okay. So for triple product we normally represent them in this format, okay. So they are normally called scalar triple product, okay. So they are normally called scalar triple products, okay. Scalar triple products, and then they are being represented as A dot B multiplied by what? C, okay. This is how they are being represented, and then in their what matrix form, we just write them in this format, okay, just like the initial explanation, okay. So we have B1, B2, B3, and then what C1, C2, and what C3, okay. So we do the same expansion just like we did for this expansion, okay, just like here. You do the same expansion and then you arrive at what your answer. Right, now there are some key points you need to know, okay. So the first point is that whenever you meet any scalar triple product, okay, you meet this kind of scalar triple product, okay, and then you do the what calculation, you find the determinants just like here, just like this format, okay. You use this example formula to find your what determinant, and then the answer you get is what greater than 0. It means that what your scalar triple product is what right-handed, okay. Whenever you expand what a scalar triple product, okay, in this form, okay, using the determinant formula, okay, just like here, okay, it's like this principle, and then your final answer is greater than 0, okay, that's positive. It means that what the scalar triple product is what right-handed system. Then whenever you do similar, okay, and then your scalar triple product is negative, okay, less than 0, it means that what your scalar triple product is what left-handed system, okay. You have a left-handed system scalar triple product, okay. Now you could also meet other principles, okay. So let's say you have what a scalar triple product, okay. Whenever you solve for a scalar triple product and then your answer is what not equal to 0, okay. So let's say you have here now, so whenever you have a scalar triple product and then your final answer is not equal to 0, okay, that principle is what we refer to as what linear independence, okay, or non-coplanar, okay. So we have what, see that linear, that scalar triple product is what linear independent, okay. So these are the 4 what important tips you need to know, okay. So they normally bring them in what either MCQs and or theory-based question, okay. So whenever you have what a triple product, okay, a scalar triple product, and then when you find your answer, okay, use your matrices to find your answer, and your answer is what greater than 0, it means that what it's a right-handed system, okay. It's a right-handed system scalar triple product, okay. And then when you do similar and then your answer is what less than 0, that's what negative, it means that what you have what a left-handed system, okay. And then again, whenever you find your scalar triple product and then your answer is what not equal to 0, okay, your answer is not equal to 0, okay, so your answer is something like 1 or 2 or whatever, okay, it means that you have what linear independence or non-coplanar scalar triple product, okay. And then whenever you have a scalar triple product, you find the what determinant of that scalar triple product, okay, and then your answer is what equal to 0, it means that you have what linear dependence or even collinear what scalar triple product, okay. So these are the 4 main tips you need to know, okay. They are very, very important, okay. You might be given a question and then you are asked to maybe find whether a certain scalar triple product is what right-handed, left-handed, linear independent, or linear what dependence, okay. So now let's take an example. Okay, so this is our question. So we have to use the scalar triple product to show that what the vectors A, B, and then what C are either what right-handed system or left-handed system, and what either linear independent or even collinear, okay. So from here you got to know that we have linear independence or non-coplanar, or what linear dependence, or what even collinear, and then we have what right-handed system, left-handed system, and then each have what their respective what rules, okay. So now let's dive right into this one. Okay, so the solution will be what we write our scalar triple what product. Okay, so now yes, so these are what are scalar triple product. So now let's do the simple calculation. So we have what 1, okay, and then we have what minus 1 4, okay, and then we have what minus 9 18, okay, and then we have what, remember that we have this is what positive negative positive, okay, so we have what minus what 4 2 4, okay, and then we have what 0 18, okay, and then we have what plus negative 7, okay, then we have this, we have 2 minus 1 0 what minus 9. So when you do the simple computation, okay, we have what 1, open your bracket, this by that, and then 9 by minus 9 by 4, we have what minus what 18, and then we have what minus what negative what 36, okay, we have 4 minus 4, open brackets, 2 by 18, that's why we have what 36, minus what 4 by 0, that's why we have what 0, and then we move on to what this negative 7, okay, so we have what this by that, 2 by minus 9, we have what minus 18, and then what minus what 0. So when you do your simple calculation, when you compute all of this, you will notice that we have our final answer to what 0. So now, so to answer our what previous question, whether it's what right-handed system or what left-handed system, okay, so you can notice that when it's right-handed system, the scalar triple product has to be what greater than 0, okay, when it's left-handed it has to be what less than 0. When it's what when your scalar triple product is less not equal to 0, it means that it was what linear independence, okay, and when it's what equal to 0, it's what linear dependence or what even collinear. So from here you can notice that our final answer is what 0. It means that our scalar triple product is either right-handed system or left-handed system, because it's exactly 0, because for scalar triple product to what left-handed or right-handed, it has to be for right-handed the final answer for what the scalar triple product has to be greater than 0, and then for left-handed it has to be less than 0, but for this it's equal to 0, so it's neither right-handed or what left-handed. And then let's move on to what linear independence or even collinear. So from here you can notice that our final answer is what 0, so it means that what our scalar triple product is what even collinear, because our principle states that when the scalar triple product is what equal to 0, it means that it's linear dependence or even collinear, okay, linear dependence or even collinear. You can also solve this what using a calculator, okay, by not going through all this what simplification and what determinants and all of that, okay. So we save the best for the last, okay. So pick up your calculators, okay, and let's perform some magic over here, okay. So now put your calculator in what matrices mode, okay. So click on mode, choose what 6, okay, choose 6, and then choose what 1, okay. So your first matrix A. This is what a 3 by 3 matrix, okay, so you choose what 1, okay. So you notice that we have 3 by 3 matrix. So now, so we start inserting our value. So we have what 1 4, okay, we have what 7, okay, and then we move on to what 2 minus 1, okay, minus 1, okay, and then we have what 4 again, and we have what 0, we have minus 9, and then we have what 18, okay, point 18. Now, so we have all our data inserted, okay. After that, just like the vectors, okay, just like using a calculator to solve for vectors, you click on what AC, okay? And then you click on what? Shift. You click on matrices, that's 4. You can see that we have matrices over here, that's 4. And then you click on what? 7. The 7 is what? Determinant, okay? So you click on 7. Now, you click on shift again, and then click on what? Matrices again. And then you choose your vector, okay? The vector was what? Vector A, okay? So vector A, so like vector A as in matrices A, okay? A, then you click on 3, okay? That's what? You can notice that what? Our final answer is what? 0, okay? So it corresponds to our answer over here. So thanks for staying with me, okay? To the end of the video. Kindly subscribe, like, comment, and share. And I will see you in the next video. We'll be talking about equation of lines and planes in the next video, okay? So I'll see you in the next video. Bye bye.